Welcome to this video on distributions of the sample proportion, part 1. By the end of this video, you should be able to define the word proportion, state what data type is used in the sampling distribution of a sample proportion, p hat, list the requirements of the sampling distribution of the sample proportion, p hat, state the mean of the sampling distribution of the sample proportion, p hat, and state the equation used to find the standard deviation of the sampling distribution of the sample proportion, p hat. Suppose a therapist collects data from her patients. Here is an excerpt from a patient intake form. Take a minute and read through these questions. As you look at these questions, what type of data is being collected in this form? Remember, we have categorical data and quantitative data. Categorical data are also called labels, and quantitative data are counts or measures. So again, looking at this form, what kind of data is represented in the answers? Well, you might answer yes or no, and then if you have a blank space, you have to write some words here. So our data is categorical data. How can statistical analysis be applied to categorical data or labels or words? Well, the answer is proportions. Well, what is a proportion? A proportion is part of a whole. Like probabilities, proportions can assume values between 0 and 1 or 0 and 100%. The population proportion is represented with the lowercase letter p. The sample proportion is represented by this symbol right here, and it's pronounced p hat. P hat, the sample proportion, is equal to x over n, where x is the number of individuals in a sample with a given characteristic, and n is the sample size. The sample proportion p hat is a statistic that estimates the population proportion p. Calculating the proportion from x and n. Suppose a counseling center found that 87 out of their 105 patients experienced depressing thoughts on a regular basis. Use this information to calculate the sample proportion p hat of patients who experience depressing thoughts on a regular basis. So the sample proportion p hat is x over n. Remember, x is the number of individuals in a sample with a given characteristic, and n is the sample size. In our case, the number of individuals who experience depressing thoughts on a regular basis is 87, and n, the total sample size, is 105. So that means the sample proportion is 87 over 105, or about 0.83 or 83%. So we can say that about 83% of the patients at the counseling center experience depressing thoughts on a regular basis. Students often confuse the population proportion p and the sample proportion p hat. Take a few minutes, pause this video, and brainstorm how you can remember which symbol is associated with the sample and which symbol is associated with the population. Then unpause this video and continue. Suppose another counseling center conducted a similar survey of their patients to find out how many of them experienced depressing thoughts on a regular basis. Would you expect the results of the second counseling center to be the same or different from the first? Pause this video, write down your answer, and then unpause it to see if you are correct. You would expect different results due to sampling variability. Because the sample proportion p hat varies from sample to sample, it is a random variable with its own probability distribution. We can create a continuous probability distribution to model p hat. Before we can describe or characterize the sampling distribution of p hat, we first need to list the requirements that have to be met in order to create a sampling distribution. So here are the requirements. The first thing is that all of the requirements of the binomial distribution must be met. That's why I had you memorize the 4 conditions of the binomial, because you're going to see them a lot when we're working with categorical data. So first of all, there have to be 2 possible outcomes, which we artificially define as success and failure. The probability of success p has to be constant across all trials. There have to be a fixed number of trials n, which we also call the sample size. And lastly, the trials must be independent. Now you notice there's a star next to independent, so we're going to more rigorously define how we know whether the trials are independent. So let's look at that. So when we collect data, we often find ourselves sampling without replacement. For example, suppose you were calling on random people and asking whether they were registered to vote. You would not want to call the same house twice. But how can sampling without replacement be treated as independent when we learn that sampling without replacement by definition means that trials are independent? Well, the answer is that we can limit our sample to 5% or less of the total population. If we do this, we can treat our samples taken without replacement as independent. So we can write this mathematically by saying small or lowercase n is less than or equal to 5% of capital N, where the lowercase or small n is the sample size and the large N or the capital N is the size of the entire population. The last requirement that we need to discuss is that the shape of the sampling distribution of p hat can be considered approximately normal, provided that the sample contains at least 10 successes and 10 failures. We usually say this or decide this by saying that NP has to be greater than or equal to 10 and NQ has to be greater than or equal to 10. That's the mathematical equivalent of saying that there is at least 10 successes and 10 failures. Sullivan introduces a slightly more stringent inequality. He says that NPQ has to be greater than or equal to 10, or as he writes it, NP times the quantity 1 minus P has to be greater than or equal to 10. So notice this is a slightly more, it's a slightly different inequality, and it actually ends up that you're going to end up needing a few more than 10 successes and 10 failures. So just make sure you use this inequality when you do your homework online. So let's summarize the requirements that we have to meet in order to create a sampling distribution for a proportion. So first of all, we have to meet all the conditions of the binomial. So that means that there have to be two outcomes. The trials have to be independent, as we mentioned. We say that lowercase n has to be less than or equal to 0.05 times capital N, or the sample size has to be less than or equal to 5% of the total population size. And we say that the probability of success P has to be constant. There must be a fixed number of trials N, also called the sample size. So that's your binomial requirements. There's one extra requirement, and that is that N times P times Q has to be at least 10. So again, all 5 of these requirements must be met in order to construct a sampling distribution for a proportion. So let's talk about the mean and standard deviation of a sampling distribution. So the mean of the sampling distribution is the population proportion P. The standard deviation has to be calculated using this equation. So we say the standard deviation of the sampling distribution of P hat, that's sigma sub P hat, is equal to the square root of PQ over N, where P is the proportion of successes, Q is equal to 1 minus P, or the proportion of failures, and of course N is our sample size. Note that you will have to calculate the standard deviation by hand, even if you follow up by putting the mean P and the standard deviation, sigma sub P hat, into StatCrunch, into the normal calculator. So here are the characteristics of our sampling distribution of P hat. For a simple random sample of size n with a population proportion P, the shape of the sampling distribution P is approximately normal, provided that all of the conditions of the binomial are met, and provided that NPQ is greater than or equal to 10. So if that's true, then we know that the mean of our sampling distribution of P hat is U sub P hat equals P, the population proportion, and the standard deviation, again, is equal to the square root of PQ over N. Having watched this video, you should now be able to define the word proportion, state what data type is used in the sampling distribution of a sample proportion, P hat, list the requirements of the sampling distribution of the sample proportion, P hat, state the mean of the sampling distribution of the sample proportion, P hat, and lastly, state the equation used to find the standard deviation of the sampling distribution of the sample proportion, P hat.